Hi everyone. In this video, we're going to go over the hydrocarbons lab, specifically the different reactions and the boiling point experiment. Now, the main purpose of this lab is to determine what the identity of an unknown compound is. So we're going to run a few tests. At first, we're going to run these tests on known compounds to figure out what our unknown compound is. And we can compare our unknown compound with the known compounds. So let's start with part A. In part A, we're going to perform reactions with bromine, Br2. And we're going to perform these reactions with an alkane, an alkene, an aromatic compound, and then of course we'll also perform this experiment with our unknown and compare its result to our previous results. So let's see what happens if we react each of these with bromine. So let's start with the alkane. Let's just pick a generic alkane like ethane. Now, initially, the bromine solution is sort of a reddish-orange color. And then when we add sunlight or heat, the bromine is going to add to the alkane. So we get something called an alkyl halide, or a haloalkane, whichever word you like to use. The other byproduct here is hydrobromic acid. And both of our products are actually colorless. So we can actually monitor the progress of this reaction based on the colors we see. If we see a reddish-orange color, that means that the reaction has not occurred because the bromine is still intact. But if we notice that the color has gone away, that means our reaction did occur because we know our products are colorless. Now, this reaction can take a long time to occur, so I'm also going to add time as one of our ingredients. Okay, so what happens if we do the same reaction with an alkene? So again, bromine has a reddish orange color. And in this reaction, bromine is going to add across the double bond. And this product is also colorless. Oops, sorry. Hit the next slide. Now this reaction occurs really quickly, so we'll just write here that this is a fast reaction. Now finally, our aromatic compound, let's show a reaction with ethyl benzene. So again, bromine starts out as a reddish orange color, but after the reaction takes place, everything will be colorless. Now, this third reaction with our aromatic compound is also a slow reaction, so we'll just add time as one of the ingredients here. So now you can test your unknown compound by reacting it with bromine and then compare it to your results. Does it react really quickly or really slowly? All right, let's talk about part B. In part B, we're going to perform reactions with something called potassium permanganate, KMnO4. All right, so in this reaction, we get an oxidation reaction. So if we react this with an alkane, we're actually not going to see a change in the color. So potassium permanganate is a dark purple color. And in this case, no reaction occurs. So we're just going to see that dark purple color stay exactly the same because the potassium permanganate has not reacted. But if we have an alkene, like the one we saw on the last slide, this will react with potassium permanganate. And what we'll see is the formation of two alcohol groups across that double bond. So this will be a diol because there's two alcohols. And we also end up forming something called manganese dioxide, MnO2, which is a solid. And the color of manganese dioxide is kind of a brown or black color. So that's how we're going to tell that a reaction occurred. We start by adding this purple compound, and then it's going to change into kind of a brownish black color. Now our last sample, which is an aromatic compound, is similar to an alkane up above in that it doesn't react with potassium permanganate. So we're just going to see that purple color persist. So then you can react your unknown compound with potassium permanganate and see if it stays a purple color or if it changes to a brownish black color. And that's how you'll know that a reaction either did occur or didn't occur, and you can try to narrow down what type of compound it is. All right, so now we're going to skip part C, which is a flammability test, just for safety reasons. But we are going to perform part D. So we're going to determine the boiling points of our different compounds. And we do know which boiling points to expect for the known compounds, but we can correct our thermometer if it is slightly off, so we can calibrate it. Additionally, we can then test our unknown compound and see if it matches any of our known compound boiling points. So the way that we do this is we connect a thermometer to something called a boiling tube. And this boiling tube is connected to the thermometer using a rubber band. Additionally, we're going to add our sample to the boiling tube because we're eventually going to boil it. And then we're also going to add a melting point capillary tube into the boiling tube. And we're going to make sure that the closed end of the melting point tube is facing up and the open end is facing down. Now, the reason we're doing this is every liquid has some vapor pressure. And what I mean by that is every liquid has some molecules that are escaping as a gas. And if we could measure the pressure of that gas, That would be called the vapor pressure. So you can imagine if we're heating the liquid, more and more gas molecules are going to escape. So the vapor pressure will keep increasing. On top of this, we also have gases that exist above our liquid. So that would be air. So air is composed of things like nitrogen gas, carbon dioxide gas, argon, oxygen, etc. But the pressure that that gas or mixture of gases exerts on the liquid is called atmospheric pressure. So the boiling point of a liquid occurs when the vapor pressure is equal to atmospheric pressure. So, for example, we know that water has a boiling point of 100 degrees Celsius. So at 100 degrees Celsius, the vapor pressure of the water is equal to the atmospheric pressure above it, which is usually 1 atmosphere of pressure, although that can change depending on the temperature that day or even the elevation that you're at. So for instance, if you live in Denver, Colorado, which is the mile-high city, the atmospheric pressure is less because you're higher up. So the gases aren't as, concentrated that high up. Okay, so what we're going to do here is this entire apparatus will be in a beaker of water. And then we're going to use a hot plate to heat up the water, which will also heat up our sample in the boiling tube. Then at a certain point, you're going to notice bubbles coming out of the melting point capillary. So what's happening there is the melting point capillary is initially filled with air from the atmosphere. But as we're heating our sample, the vapor that's forming is going to enter the capillary tube and displace the air that's inside of it. So that air is going to come out of the melting point capillary as a stream of bubbles. And eventually that entire melting point capillary will be filled with vapor from our sample. So for instance, if it's an alkene, then we'll have alkene gaseous molecules filling up that melting point capillary. So we're going to wait until we're past the boiling point of the solution, and then we're going to turn the heat off, let everything cool down, and at a certain point, the pressure inside of the melting point capillary is going to draw liquid up inside of the capillary, and that's the point at which we have our boiling point. So in the video you're going to watch, you want to wait until you see liquid rising up inside of the melting point tube, and that will be the boiling point of the liquid. Now this isn't a perfect experiment. There can, be some error here. So I'll have you watch the experiment once, and then I'll give you a document with the recorded boiling points for each liquid, as well as the unknown liquid. So you can try to identify and match what your unknown compound is. And also that will avoid having to watch this same experiment 4 times because it can be a long process. All right, so if you have any questions about the lab, please feel free to message me or leave your question on the question and answers discussion board.